Hello students, good morning to all. Welcome to your beautiful channel Frijan. Today we discuss electrostatic potential and capacitance, second lesson 12th standard. In this one we discuss effect of dielectric when placed in parallel plate capacitor. Dielectric is placed in the parallel plate capacitor. What is the effect? How electric field changes, potential changes, how capacitance changes, what are the advantages that we discuss in this class. See, myself is ready. It is your cute channel Firjan. See, we discuss effect of dielectric in parallel plate capacitor. First, parallel plates. See here, it is the parallel plates. See, it is the parallel plates. It is plus positive charge, here negative charge. See, it is plus q, it is minus q. See, distance between the plates is d, yes na? So it is area is a and this area is a, yes na? See here, its charge we can write it as surface charge density sigma, we can write plus this surface charge density we can write sigma minus, we can write sigma means surface charge density, means charge per unit area. In unit area how much charge is there, that we can represent sigma, that is the surface charge density. Here see, we can place dielectric in between the plates, it is the dielectric. So dielectric means, see we discuss about first dielectric. See, dielectric means, see dielectric, it is not conductor, it is not conductor, it is a not insulator, not insulator, it is not semiconductor also, semiconductor. So it is a different class of material, it is a different class of material which allows, sorry, which do not allow, which do not allow electric current but allows development of electric field. See here, listen once, it is, this is the dielectric, it is not a conductor, not a insulator, not semiconductor, it is different class of material which do not allow electric current but allows development of electric field. So for example, it is most of cases solid. So what is the example now? Glass and mica, these are the examples of dielectric. What not dielectric is the different class of material which do not allow electric current but allows development of electric field, development of electric field. It is not a conductor, not insulator, not semiconductor, it is solid substance, mostly it is glass and mica, it is glass and mica, it is the dielectric. See here, electric field is always positive to negative is there, it is the direction of electric field. See here, in this dielectric atoms, molecules is there. For example, here see, molecule is there, this is the molecule, yes na? In this one, see, all negative charges polarize one side and positive charges polarize another side. See here, here positive is there, it is attracting, so means positive charges polarize this side, sorry, negative charges polarize this side, positive charges polarize this side. This all means like that, here all negative charges this side polarizes, C means moves one side, and all positive charges moves this side. See, it is positive charges. See here in dielectric also again this is negative charges, it is positive charges. See, we can write here sigma I means charges are induced. Here these are the charges. Now how it is now, he see charges are induced due to external electric field. Due to external electric field, charges are induced. Due to that, here see, it is negatively charged charges, it is positively charged, induced negatively charged. So that's why we can write it as induced surface charge density. It is the induced surface charge density positive, sigma plus sigma I minus this one, it is sigma I plus, it is induced charge density. So we can write induced charge density, induced charge density we can write sigma I. See here, due to here induced charge density minus induced charge density, it is plus charge density. What is the electric field direction now? Always positive to negative. It is the direction of electric field. It is induced electric field. Induced electric field. This induced electric field is due to induced charge densities. Yes, now it is plus to minus. So this is the direction of induced electric field. It is the direction of external electric field. So E naught is the external electric field. I write here EI. It is the induced electric field. It always opposes external electric field. See, EI is the induced electric field. It always opposes E naught. See, is it visible? Yes, okay. See, EI is induced electric field. It always opposes E naught. See, E naught now external electric field. What this one? External electric field. External electric field. See here, what we can write now? E net. What is the net electric field? So means E net due to external electric field. Yes, na? E net we can write E net equal to what? E naught minus EI. E naught means external electric field, EI means induced electric field. It is induced external electric field, it is induced electric field, it is E naught. See here, it's here this dielectric has dielectric constant. What is that now? K. Here K means dielectric constant. We can write first here dielectric constant. See, dielectric constant. So what is dielectric constant now? It is the property of material. It is the property of material which decreases electric field. Decreases the electric field as compared to electric field in air or vacuum. Electric field in air or vacuum is called dielectric constant. It is K. See here, dielectric constant means, so dielectric constant is the property of material which decreases the electric field as compared to electric field in air or vacuum is called as dielectric constant. See here, K means here dielectric constant. See, first here it is the parallel plates, it is plus Q minus q, this charge surface charge density is sigma plus, this surface charge density is sigma minus. See, due to this external electric field in this dielectric material, so dielectric now means it is the different class of material which do not allow electric current but allow a development of electric field. It allows development of electric field. Inside dielectric, atoms, molecules is there, in this one charges is there, these charges are polarized. Positive charges all polarized this side, negative charges this side. See, due to this positive and negative charges, electric field is positive to negative inside. So that electric field here we can say that induced electric field. Induced electric field. This EI is the induced electric field. It always opposes the E naught. E naught means external electric field. See here, charges are induced due to external electric field. Induced charge density we can write sigma I. So it is sigma I minus sigma I plus, means surface plus induced surface charge density. Here induced surface charge density minus. Yes, na? Electric field plus 2 minus. See, what is the net electric field now here? E naught minus EI. See, what is the net electric field now here? See how many times electric field decreases as compared to electric field in air, that we can write dielectric constant. So that case, what is the net electric field now here? E naught by K. It is dielectric constant. See, that equal to E naught minus EI. It is induced electric field. See, actually E naught equal to single plate na sigma by 2 epsilon naught. Here parallel plates. So we can write sigma by epsilon naught. It is the E naught value, means electric field equal to sigma by epsilon naught. Here we can write, see, E naught means sigma by epsilon naught K, that equal to E naught means sigma by epsilon naught minus sigma I by epsilon naught. So means what is the electric field? Means sigma by epsilon naught. Sigma means surface charge density. Surface charge density means sigma equal to Q by A, charge per unit area. So means here E naught means sigma by epsilon naught. I write here E naught by K na. So means E naught sigma by epsilon naught K, sigma by epsilon naught minus sigma I by epsilon naught. See, sigma I by epsilon naught changes to this side. See, sigma I by epsilon naught, that equal to, this is sigma by epsilon naught minus, it will change that side, means minus sigma by epsilon naught K. See here, sigma I by epsilon naught, here sigma by epsilon naught common na, here 1, here 1 by K. So means here epsilon naught cancel. What we get now here? Sigma I equal to sigma into 1 minus 1 by K. It is the induced surface charge density. For finding induced surface charge density, we have a formula. So that is sigma I equal to sigma into 1 minus 1 by K. Here K means dielectric constant. Dielectric constant means it is the property of material which decreases the electric field as compared to electric field in air or vacuum. So that we call it as dielectric constant. K is the dielectric constant. What is the induced surface charge density developed in dielectric constant now? It is the formula sigma I equal to sigma into 1 minus 1 by K. Here sigma means surface charge density, 1 minus 1 by K. K means dielectric constant. It is the basic concept. See here. So what happened now here? Because of this, what now first case here, electric field decreases where to where na, E naught to E naught by K. Where to where it decreases? E naught to E naught by K. Means when dielectric is placed in between the plates, that case this E naught is decreases to E naught by K. Means K times. K means here dielectric constant. That only, see here, it is the property of material which decreases electric field as compared to electric field in air or vacuum. Means K times it decreases. That's why what is the electric field resultant? E naught by K. So means E naught will be changes to E naught by K. What about potential? What about capacitance? That we discuss. What about electric field? Electric field is decreases to E naught by K. Now we discuss what about potential? What about capacitance? See here. So this understood na? So dielectric means it is different class of material which do not allow electric current but allows development of electric field. So means EI means individual charge, individual electric field, it always opposes E naught. So means what is the net electric field na? So E naught by K equal to E naught minus E naught I. So what is the surface individual surface charges na? Sigma I equal to sigma into 1 minus 1 by K. Yes na? See, now we discuss what is what about potential difference when dielectric is placed. See, first one what? So electric field, when dielectric is placed between the plates, what about electric field na? We discussed already. What is the electric field? First one, see, electric field is decreases when dielectric is placed between the plates. That case it decreases E naught to E naught by K, E naught to E naught by K. When what about potential? So means potential difference. Right now here potential difference. See, potential difference, what na formula? Delta V equal to minus of E dot delta R. So means here, so magnitude we can take na, this minus no need. See here, it is without dielectric, it is without dielectric. This is the formula. See, without dielectric na, delta V equal to E dot delta R. Delta V means change in potential, delta R means distance between the plates. See here, delta V equal to E. What happened here? E is when dielectric is placed between the plates, E naught changes to E naught by K. Means instead of E, what we can write? E naught by K into delta R means what is the distance here? D we can write. Means E naught D by K. Means E naught D means V naught by K. Means here see, what now here? Potential decreases where to where? V naught to V naught by K. Potential also decreases from V naught to V naught by K. What about capacitance? See here, capacitance. Capacitance now what's the formula? C equal to Q by delta V. Q means here charge on positive plate, delta V means potential, change in potential or potential difference. See here, what is the capacitance now here? C equal to Q means same. Delta V now what we get? V naught to V naught by K. When dielectric is placed now, it will changes from V naught to V naught by K. Instead of delta V, we can write V naught by K. So means Q K by V naught we can write. Q by V naught means what we can get? C naught into K. Means see here, capacitance is increases. Here see, what now here? Capacitance increases C to C naught K. Increases from where to where? C to means C naught to or C to C naught K. C to C naught K. It is the changes happen when a dielectric is placed between the plates. What is the first one now? See, electric field decreases from where to where? E naught to E naught by K. When dielectric is placed between the plates, what happen now? Electric field decreases E naught to E naught by K. K is here dielectric constant. Dielectric constant means it is the property of material which decreases means the number of times, right here, the number of times which decreases the number of time electric field, or the number of times electric field decreases as compared to electric field in air or vacuum. See, which decreases the number of times electric field as compared to electric field in air or vacuum. So that we call it as dielectric constant. See here, E naught to E naught by K. So electric field is decreases from E naught to E naught by K. What about potential? Potential decreases from V E naught to V naught by K. See here, where to where it decreases? V naught to V naught by K. Here E naught to E naught by K. What about capacitance now? C naught to C naught by K or C to C naught by C naught K. Means capacitance increases, potential decreases, electric field decreases. Yes na? See, when dielectric is placed between the plates, what are changes now here? See, electric field where to where, so E naught to it decreases E naught by K, yes na. So potential now it is, so V changes V naught to V naught by K. What about capacitance? Capacitance changes from C naught to C naught K, C to C naught K, C to C naught K means electric field decreases, potential decreases, capacitance increases. Means when dielectric is placed between the parallel plates, electric field decreases, potential decreases, and capacitance increases. This is the, when dielectric is placed in between the parallel plates, what are the effect na? Electric field decreases, potential also decreases, capacitance increases. What are the advantages of dielectric when placed between the parallel plates? See here advantages na here. What is the first advantage na here? See first one. So we have some advantages. Advantages of dielectric placed between plates. So between plates dielectric is placed. What is the first advantage na? It provides stability, stability to the plates. It provides stability to the plates. See, whenever dielectric is placed between the plates, it gives stability to the plates. Second one, it to prevent, means dielectric prevent from, means plates, prevent the plates, sorry, prevent the plates from sticking to each other. Sticking to each other. See, so dielectric is not there now, it is very close. What happen, it will positive negative attracted, so means what happen, stick each other. So means from that it will prevent, means it prevent the plates from sticking to each other. Third one, see, it increases capacitance, it increases capacitance. Fourth one, see, it prevent, it can prevent from breaking of medium or breakdown of medium. These are the advantages of dielectric placed between the plates. What is, it can prevent from breakdown of medium na? Here dielectric is there, in between them what is there, air only is there, air molecules are neutral. Because of this electric field, air molecules, high electric field is there na, it will pull. So what happen, that medium is break, so that is, from that it will prevent, means it can prevent from breakdown of medium. So these are the advantages of dielectric placed between the plates. What is the first one? See, it provides stability to the plates. It will give more stability to the plates. Second one, it prevent plates from sticking to each other. No dielectric now it will stick to each other. So under neutralize. So that from that it will prevent. See, it increases the capacitance. C to C naught K means K times it increases. So means it can prevent from breakdown of medium. These are the advantages of dielectric when placed between the parallel plates. So it is about effect of dielectric. Now we discuss what is the value of means dielectric. What is the dielectric constant for metals means or conductors? So that we discuss. See, we can find. See here, what is the value of K for metals or conductors, that we discuss. See here, what is the value of K? K means what here? Dielectric constant. Dielectric constant means it is the property of material. The number of times electric field decreases as compared to electric field in air or vacuum. How many number of times electric field is decreases when dielectric is placed between the plates? So that number of times we call it as K. See here, what is the value of K? For metals. See for example here it is the parallel plates. Here dielectric is there. It is dielectric is here metal. Yes na. So metal dielectric is there. So metal means conductor. See it is positive. It is negative. See, so electric field is where to where? Positive to negative electric field is there. It is the electric field. What is it is plus Q? It is minus Q. What is the distance between them now here? D. So what is the electric field inside the conductor? Electric field inside conductor is 0. What is the net actually? E net equal to what? E naught by K. So means this dielectric constant is K. So how many times it decreases? The number of times electric field is decreases as compared to electric field in area or vacuum. So that we call it as dielectric constant. Here how many times decreases? K times E naught by K. What is the electric field inside the conductor or metal? So 0. Here we can write 0. That equal to E naught by K. K changes to here. K equal to E naught by 0. E naught by 0 means infinity. What is the dielectric constant of metals now? Infinity. Dielectric constant of metals is infinity. K value is for metals is infinity. For example, see here sigma I. So individual charge, the individual surface charge density when dielectric is placed between the metal, placed between the plates. So for that, what is the formula? Sigma I equal to sigma into 1 minus 1 by K. It is the formula for surface individual surface charge density of dielectric when it is placed between the plates. So what sigma I equal to sigma into 1 minus 1 by K. Here K means what? Dielectric constant. What is the dielectric constant of metal? See here infinity. Sigma I equal to sigma into 1 minus 1 by infinity. So 1 by infinity means 0. So what we get here? Sigma I equal to sigma into 1. So means sigma I equal to sigma. Means how many charges in in capacitor plates is there, that many charges developed in the conductor or metal when it is placed between the plates. Yes na. So means individual surface charge density which is equal to surface charge density, both are equal. So in the same way, for example, see when sigma I is greater than 0 or epsilon naught is net epsilon naught. So we can write here. So means E net is greater than 0. So means not equal means 0. It is electric field is what here? Individual electric field is 0. Net electric field. So means individual electric field 0 na means what here? Net electric field na K equal to epsilon naught by E naught by 0. So we get K value infinity. Means here external electric field, individual electric field, both are equal. That's why net electric field what we are getting? 0. So when net electric field is greater than 0, what about sigma I na? Sigma I is less than sigma. Else wise, see sigma I is less than sigma when it is na E net is greater than 0. This is the what is the value of K for metals na? Infinity. How it will find out? See here it is positive place, negative place, in between them dielectric is there. What is dielectric here? Metal dielectric is there or conductor is there. Electric field inside is 0. E net equal to E naught by K. So E net is 0. E naught by K na. K changes to here. K equal to E naught by 0. So infinity we can get. K value is what is the K value for metals na? Infinity. We want to find out surface charge density, individual surface charge density. For that formula sigma equal to sigma into 1 minus 1 by K. Sigma into 1 minus 1 by K means infinity 0. So 1 sigma equal to sigma means individual surface charge density equal to surface charge density. Because of that electric field inside the conductor is 0 or in dielectric is 0, that dielectric is metal. So that case, for example, E net is greater than 0, that case sigma I means individual surface charge density is definitely less than surface charge density. Yes na. So this is the about what is the K value for metal na? Infinity. So next one, see what is the capacitance of the parallel plate capacitor when it is partially filled with dielectric. See capacitance of parallel plate capacitor, it is will partially filled dielectric. See capacitance of, we can write now So this effect of dielectric is understood now. So when dielectric is placed, electric field is decreases E naught to E naught by K, potential V naught to V naught by K, capacitance K times increases. Yes na. So when see here, what about the capacitance, sorry, dielectric constant of metals na, it is infinity. See here, when dielectric is placed between the parallel plates, capacitance increases K times, means dielectric increases the capacitance K times, means dielectric makes the capacitance to reach K times. How many times it reach na? K times it increases. Yes na. See what now here, now we discuss capacitance of partially filled dielectric, partially filled dielectric between plates, between between plates dielectric is filled but partially filled. That case, what about capacitance? See here, it is the plates, another plate, here see, it is the dielectric, it is the dielectric, so remaining is here, see, empty. So here see, it is positive charge, it is here negative, here see, electric field is positive to negative, it is E naught, it is plus Q, it is minus Q. See here, in this one, in dielectric, charges are developed, it is minus, it is plus. See here, its dielectric constant is K, its thickness is T. Yes. See here, its thickness is D. This definitely, electric field is what? Positive to negative. So this is the direction of electric field. Yes na. See here, what is the here? Distance is here D minus T. What is the distance between each na? Partially filled na, so remaining part is D minus T. So it will, here see, what is the capacitance we find out? Capacitance of partially filled dielectric between the plates. So that case, delta V equal to what? E dot D. Yes na. Here see, here we have 2 is there, this is one, this is one, this is E naught, it is E naught by K, E naught by K, it is electric field is here E naught, it is E naught by K, E naught by K, means delta V equal to, we can write E1 D1 plus E2 D2. It is one capacitor, it is one capacitor acting this one. See, delta V equal to here E1. E1 means what? Electric field is E naught, distance is D minus T. Why? Because this thickness is, we can remove from the total distance, this is D minus T, plus E2 is, here see, what is the thickness? T. What is the electric field now? E naught by K. Why? Because, so means when dielectric is there, so electric field is decreases K times. The number of times electric field decreases as compared to electric field in air or vacuum. So that we call it as K. So how many times it decreases? K times. So that's why E naught into E naught by K. What is the thickness here? T. Yes, now see, here E naught is there, we common. See here, what we can write? D minus T plus T by K. Yes na. See, delta V equal to, so delta V equal to what? E naught into D minus T plus T by K. E naught means, we know, electric field between the parallel plates is sigma by epsilon naught. It is the formula for electric field. See, we can write here sigma by epsilon naught D minus T plus T by K. Yes na. See, sigma means what here? Surface charge density, charge per unit area. See here, so Q by A epsilon naught D minus T plus T by K. It is the change in potential between plates when plates are partially filled with dielectric. Yes na, partially filled na, that case, what is the change in potential? Delta V equal to Q by A epsilon naught D minus T plus T by K. Now what we find out na? Capacitance. See, capacitance na, C equal to what? Q by delta V. It is the capacitance. C equal to Q by Delta V means this one, Q by A epsilon naught into D minus T plus T by K. It is the change in potential. Q cancel. What we get here? It will changes to numerator A epsilon naught by D minus T plus T by K. It is the capacitance of the partially filled dielectric between the plates. When dielectric is partially filled between the plates, that case what is the capacitance now? C equal to A epsilon naught by D minus T plus T by K. It is the capacitance of the dielectric partially filled between the plates. Yes, now what is the capacitance? C equal to A epsilon naught by D minus T plus T by K. See again once I explain. See here, capacitance of partially filled dielectric between the plates. Here is before fully means placed. So that case, what now we can get? Capacitance increases K times. So means K epsilon naught A by D we can get. But here see, in this case, here now it is K, it is dielectric constant of this dielectric E naught by K electric field. It is E naught is the electric field in between the plates. Yes, it is dielectric is then in this case E naught is electric field is E naught by K. So delta V equal to what? Electric field into distance. So electric field now here, this one E1 D1, this one E2 D2. E1 means E naught, D1 means distance is D minus T. E2 means T, E naught means E1, E2 means E naught by K, distance is D. So E naught by K into T. Here E naught is common, so D minus T plus T by K. So E naught means sigma by epsilon naught for parallel plates. So D minus T plus T by K. Sigma means Q by A, surface charge density, charge per unit area, A by Q by epsilon naught A, D minus T plus T by K. So we want to find out capacitance. What is the capacitance of the parallel plate capacitor when it is filled with partially filled dielectric? So that is C equal to Q by delta V. C equal to Q by delta V means it is the value Q by A epsilon naught. I write D minus T plus T by K. See here, Q cancel, A epsilon it changes numerator, A epsilon naught by D minus T plus T by K. It is the formula for capacitance of the partially filled dielectric between the plates. What is the formula? Epsilon naught A by D minus T plus T by K. For example, see, two capacitors we can fill, sorry, two dielectrics is placed. What happened? So what is the capacitance that we find out? For example, see here, it is the parallel plates. It is parallel plates. It is plus. It is minus, negative charge. See here, two plates are placed. Two dielectrics are placed. It is one. Its capacity means dielectric constant is K1. So means E naught by K1 electric field. See, it is another dielectric. See here, it is dielectric constant is K2. It is electric field is E naught by K2. Its distance is T1, thickness is T2. Total is D. Yes, na? See now here we can write it is plus Q, it is minus Q. Yes, na? See, we want to find out what is the capacitance of this parallel plate capacitor. So capacitance we find out. Capacitance of parallel plates when filled or when placed different different dielectric between plates. So that case we can find out what is the capacitance. See, for that, what not change in potential we can write. What is the change in potential? See, E into D. Here what? E1, actually E1 D1, E2 D2, E3 D3. 3 is there here. One is empty space or vacuum, another one is one dielectric constant K1, another one is dielectric is K2. See here, delta V equal to what? E1 D1 plus E2 D2 plus E3 D3 we can write. So means E1 means E naught, this one, this one. So what here? So E naught means here E naught, E1 means E naught, D1 means this is distance, thickness is T1, this T2. So remaining na D minus T1 minus T2 na. See D minus T1 minus T2, that is the thickness, plus see this thickness subtract from the D, remaining space we do. So that I write here D minus T1 minus T2 plus E2 means here E naught by K1, E naught by K1, distance is what na here thickness T1 I write, plus E3 means E naught by K2, thickness is T2. Here see all have E naught na, we common E naught, what we can write T minus D1 minus T2 plus T1 by K1 plus T2 by K2. Yes na, see it is the change in potential between the parallel plates when two dielectrics are placed between the plates. When two dielectrics are placed between the plates, that case what is the change in potential na? E naught into D minus T1 minus T2 plus T1 by K1 plus T2 by K2. This E naught means what we can write sigma by epsilon naught D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Yes na? See sigma means before only we know sigma means what? Charge per unit area. We can write here Q by epsilon naught A into D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Yes na? It is delta V. It is the change in potential when two dielectrics are placed between the plates with a different dielectric constant. What is then? Q by A epsilon naught A D minus T1 minus T2 plus T1 by K1 plus T2 by K2. We want capacitance. So capacitance equal to what? Q by delta V. What is Q? Q same. Delta V means Q by epsilon naught A into D minus T1 minus T2 plus T1 by K1 plus T2 by K2. It is. So Q cancel. What we can get capacitance? So epsilon naught A, it will change to numerator by D minus T1 minus T2 plus T1 by K1 plus T2 by K2. It is the capacitance of parallel plate capacitor when it is placed between them two different dielectric materials we can place. That case what is the capacitance na? It is the capacitance of the parallel plate capacitor. What is that one? C equal to epsilon naught A by D minus T1 minus T2 plus T1 by K1 plus T2 by K2. Yes na? This one, this is the capacitance of parallel plates plates when places different dielectrics between the plates. Yes na? See now we can draw the electric field versus distance, we can draw the graph, and potential versus distance we can draw the graph. See for that, see first we can draw electric field versus x for partially filled partially filled dielectric. Yes na? See here partially filled dielectric, it is the dielectric means parallel plates, it is partially filled, it is the dielectric here. So dielectric, its constant is K, so it electric field is E naught by K. Here C plus, here minus. Yes na? See it is plus Q, it is minus Q, distance between them is D, it is thickness is T. Yes na? See this case what is the change in potential na? We can write change in potential is epsilon naught A by D minus T plus T by K. It is the change in, sorry, what is the change in potential na? Q by epsilon naught A into D minus T plus T by K. It is the Q into D minus T plus T by K is the by epsilon naught A is the change in potential. What is the capacitance now here? Capacitance equal to epsilon naught A by D minus T plus T by K. It is the capacitance of the partially filled dielectric between the plates. Yes na? See what now here, it is electric field is E naught maximum. So electric field is positive to negative. So here electric field is E naught by K. We want to draw the electric field versus X graph between electric field versus X. See I write here, it is X, here D, here 2D. It is electric field we can take. Yes na? On y axis electric field, x axis distances. Here see electric field is what? E naught. So means maximum. Yes na? See in this is, so means up to what here d distance. It is the electric field for air medium. Dielectric, now what happened now here, electric field is decreases k times. K means number of times electric field decreases as compared to electric field in air or vacuum. So means here it decreases. So means where, see 2d up to 2d, yes now it is the electric field due to dielectric. When dielectric is placed, electric field is E naught by K, E naught by K. Yes na? See it is for without dielectric, it is for dielectric. So without dielectric na maximum electric field, with dielectric na it decreases to E naught by K. So that's why electric field also some decreases. It is E naught, it is E naught by K for it is for dielectric. Yes na? Now see potential versus, here we can take change in potential versus distance x. Yes na? See here we can take potential x, y axis potential, x axis distance. Here d, here 2d. See here what is the potential now here, delta v. Delta v equal to E naught. See potential now here to here, what happened now here maximum. So along the electric field I write here electric potential is decreases along electric field. Along electric field electric potential is decreases. Here maximum, here na decreases means it will from here to here decreases. So how it will decreases na? So maximum decreases. Yes na? So dielectric, see here for this it is up to d distance, here maximum is there, it is v naught. So what happened now here, from here to here it decreases. So up to this one, see up to d distance, from here d minus t distance, it is d minus t distance, it is t, it is d minus t, up to d minus t distance from here to here. What is the change in potential now? It is the change in potential, it is means what now, theta 1 angle. See after that dielectric is there, dielectric place na. So here also potential changes, what na here E naught by K into D, means here it is V minus E naught D. After that na here up to here, see it is potentially changes less only, electric field na, so less only is there here. See it is this one, see this is the change in electric potential. See what na here it is, see it is theta 2. Theta 2 here is V naught minus E naught D minus E naught D by K. It is the change in potential. See here, its theta 1 is greater than theta 2. In this case, what is the change in potential now? V naught minus E naught D minus E naught D by K. E naught D by, here change in potential is maximum is there, here minimum is there. So theta, that's why theta 1 is greater than theta 2. It is the change in potential versus x. It is the electric field versus x graph for electric field versus x. So it is change in potential versus x distance. Yes na? So these are the graph for partially filled dielectric. For example, see E versus x and delta V versus x for two dielectric is placed between the plates. Two dielectrics is placed between the plates. See, for example, see here we can take, so E versus x and delta V versus x, we can draw the graphs. Yes na? For that, see what we can take now here, two dielectrics is placed, it is plus it is minus, here see, minus, here one dielectric, its constant is K1, dielectric constant, its thickness is T1. See, one more dielectric here, it is C, here T2. See here, its electric field is E naught by K1, its electric field is E naught by K2. So change in potential is this one, E naught D by K1, its change in potential is E naught D by K2. See here, it is distance is this one, D. Here we can take dd distance now. Here D, here D, here D, here also D we can take. Yes na. See how many is there total now here. See D, 1, 2, 3, 4, 5. So means 5 D's. Means I draw here first electric field. See, electric field I draw first here X. Here take D, 2D, 3D, 4D, 5D. First electric field I draw now. Here see, E naught. It is E naught by K1. It is E naught again. It is E naught by K2. It is again E naught. See here, dielectric constant na K1, K2, K we can take. See here, electric field maximum first one. See what na when. So empty means air is there. So that's why it is maximum. So E naught. Yes. See next na, here see, this one second one dielectric is there. So what we can now, E naught by K. So definitely it is, see here, this one, it is E naught by K. Yes, 1. So it is again empty space means air medium. So means again it is maximum. See here, it is maximum. Again electric field is this one. See again, so dielectric is there means it changes. See here, it changes. Again see here, empty space is there, again maximum. So it is the electric field. Yes, see, so like this, it is the graph for electric field versus x distance. Yes na. So this is the electric field versus x distance. So potential na, we can draw potential for this. See here, I draw here only. I take here, it is V versus x. Yes na. See it is V. See we can take here V naught maximum. See D, 2D, 3D, 4D, 5D. Yes na. See here, first one. So it is what now here, air medium. So means empty space. So that case potential change is maximum is there. Yes na. See later, see potential change, dielectric is there, it will decreases. See here, it is decreases. Here less one is less is there. So this one here see again. So means dielectric means empty space is there, again it will maximum is there. See here, this one. So after that, see here again dielectric is there, less decrease is there. Yes na. See again empty space is there. So this one, see here, it is here now means E naught minus E naught D by K. Yes na. It is E naught this one. So we delta V na, delta V equal to E naught into D. Here right, E naught into D, this one. This one E naught D minus E naught D by K1. Yes, it is again. So E naught D minus E naught D by K1 minus E naught D. Why now here air space, it is theta 1, it is theta 2, it is theta 3, it is theta 4, it is theta 5. Yes na. See here, in this case dielectric is there na, change in potential less is there, empty is there na, maximum is there. See here, E naught D, V naught minus E naught D. Yes, V naught minus E naught D. See once again, it is potential, it is x distance. Yes na. See here, maximum potential is V, it will changes to, so means here say here maximum is there, in going on what happened, potential change. Why? Because along the electric field potential decreases, that's why V naught to it changes V naught minus E naught d, E naught d, V naught from V naught E naught d subtract, we get the here potential. So next now here to here dielectric is there, second one is dielectric is there, so means dielectric case is what, E naught by d is the potential, here is what, V naught minus E naught d, here na E naught d by k we can subtract, means V naught minus E naught d minus E naught by k is the here potential. Here potential na V naught minus E naught d minus E naught d by k1 minus E naught d, again here empty space is there, so that change in potential na here E naught d, E naught d, yes na, so that's why see here what now, V naught minus E naught d minus E naught d by k1 minus E naught d minus dielectric is there again, so means E naught d by k2, yes na, this one see here V naught minus E naught d minus E naught d by k1 minus E naught d minus E naught d by k2 minus E naught d, yes na, understood this one. See here maximum I write here, here is potential is V naught, here what now, V naught minus E naught d, here potential V naught minus E naught d minus E naught d by k1, here potential V naught minus E naught d minus E naught d by k1 minus E naught d, here potential V naught minus E naught d minus E naught d by k1 minus E naught d, here na final potential na here V naught minus E naught d minus E naught d by k1 minus E naught d, see 1 minute, here V naught, here V naught minus E naught, here V naught minus E naught d, E naught d by k1, here V naught minus E naught d minus E naught d by k1 minus E naught d, yes, here E naught V naught minus E naught d minus E naught d by k1 minus E naught d, here minus E naught d by k2, here minus E naught d by k2 minus E naught d, yes na, see here potential V naught, here potential is this one, here potential is this one, here potential is this one, here potential is this total, so here potential is this one, so that only I write here, so means here maximum, here is V naught minus E naught d, here is V naught minus E naught d, dielectric is there, so E naught minus E naught d by k, next here normal air medium na E naught d, E naught d by k1 minus air medium na E naught d, yes na, so here again dielectric is there, theta 4 and theta 2 is dielectrics, it is dielectric, yes na, dielectric, this also dielectric, yes na, so dielectric, see here V naught minus E naught d, E naught d by k1 minus E naught d minus E naught d by k2, so means here k1 k2 na we can take k na, that case this two angle is same, I write later, see V naught minus E naught d minus E naught d by k1 plus E naught d minus E naught d by k2 minus E naught d, yes na, see here it is maximum, it is here what is the potential, it is here potential means what na, this one minus this one minus this one, that only right here, see V naught minus E naught d minus this potential what, E naught d by k1, for here potential na, see V naught this one this minus this difference, what is the here, E naught d is the potential, so that difference, so here na V naught this total we can write V naught minus E naught d, E naught d by k1 E naught d, so here to here what is the potential difference, E naught d by k2, that I write here na, see this total minus this potential difference, what is the potential E naught d, that only I write, so that is the here, yes na, see here theta 2 equal to theta 4 is less than theta 1 equal to theta 3 equal to theta 4, yes na, so it is the condition, yes na, this is the graph delta V versus x. For example, see here when one metal one dielectric is there, conductor one dielectric is there, that case what is the electric field versus that one we can write here, see it is the graph, sorry, dielectric, it is plus, it is minus, yes, see, it is the dielectric, yes, it is metal. So metal means electric field 0, yes na, here see electric field is E naught by k, here this distance is d, this distance d, this distance d, 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 yes na, total is, so what now here 1 2 3 4 5 d, total is 5d we can write, yes na, see here it is plus q, it is minus q, yes na, it is k1 k2, k2 is 0, k2 is infinity, yes na, so we can write now here, now draw the E versus x na, electric field versus x, see I draw here, it is the electric field, x axis is what na distance, here electric field, so what na maximum E naught, it is for you can write here d, 2d, 3d, 4d, 5d, see here, so d na here empty space, what is na electric field maximum, what na here E naught, so next na, so dielectric is there E naught by k, so somewhat decreases, it is here see E naught by k, yes na, see this one again empty space, so means empty space means here air medium na, so air medium means it is maximum again, yes na, it is the electric field E naught, see here this one na, so dielectric is there means metal is there, electric field is 0, here it is the electric field, yes na, so again next na empty means air medium, so means air medium means this one, it is the electric field, yes na, see it is E naught, here E naught, here E naught by k, this one again E naught, it is also E naught, electric fields, yes na, see here maximum, here E naught by k, here maximum, here is 0, that's why here only is there electric field for metal, it is for metal, yes na, see again here electric field maximum, it is the E versus x graph, see now we can draw V versus V versus this very important, see V versus x, how it will change, see here V versus x, here x, here see d, here 2d, here 3d, here 4d, see here 5d, yes na, 5d, see here x, it is potential, see potential now starting maximum what V naught, later now what happened here, it is here we continue, here maximum, so means what is the potential here E naught d, it is E naught d by k, here E naught d by k na, here potential na, see electric field 0, it is 0, yes na, here E naught d again, it is potential is, so over this is, yes na, see it is here V naught, it is maximum V naught minus E naught d na, here we can potential we get minus E naught d by we can na, here potential we can get, it is again E naught d, yes na, see we can write now here first one, see first one, this one, it is actually potential is decreases from V naught to here V naught to minus E naught d, it is, yes na, see what is the angle now here theta 1, next see again dielectric is there, dielectric means potential change is less only is there, less means this one, see here, see less, see here this one, it is theta 2, what is the potential now here V naught minus E naught d minus E naught d by k, yes it is the potential, see next this one, so 3d na, again 3d na, so this one, so means air medium, so again more decreases, yes na, see it is, it is this one, so it is actually this is theta 3, what is the change in potential here E naught minus E naught d minus E naught d by k minus E naught d, why not again here air medium dielectric again air medium, yes na, so next metal is there, yes na, after dielectric metal, what is the electric field 0, potential same constant, here same no change, so it is what na here V naught minus E naught d minus E naught d by k minus E naught D. Same only. Again what now here it decreases. See here same. Yes now what now here V naught minus E naught D minus E naught D by K minus E naught D minus E naught D. It is the change in potential. Here what? Theta 4. Yes na? See here what na here theta 2 is less than, I write here condition theta 2 is less than theta 1 equal to theta 3 equal to theta 4, means theta 1 theta 3 theta 1 theta 3 theta 4 same decrease change in potential. Yes na? Theta 2 only less. Why? Because dielectric is there. Yes na? See here V naught, here V naught minus E naught D, here V naught minus E naught D minus E naught D by K. Why? Because here electric potential change in potential is E naught D. Here change in potential is E naught D by K. Here change in potential is E naught D again. Here 0. So that's why here maintains constant. Yes na? Here see E naught D. So means this one minus this minus this minus this minus this na. Here we can get the potential, minus this one we can get na. So potential. This is the change in potential or potential versus X graph. Yes na? It is electric field versus X graph. For one is dielectric, another one is conductor or metal, dielectric metal. Yes na? So this is the effect of dielectric when effect of dielectric placed between the parallel plates, placed between the parallel plates. See so some problems is there, we can do now that also. See once, see here what is the first one now. See for example it is the dielectric, sorry, capacitor. It is filled here. One is it is capacitor dielectric constant is K1, its dielectric constant is K2. It is filled with here see dielectric. Yeah, it is the dielectric. See it is dielectric constant is K2. So means this capacitance is C1, this capacitance is C2. It is plus Q minus Q here. What is the here we find out now? Find capacitance, equivalent capacitance. Find equivalent capacitance. Find equivalent capacitance. For that now see here we can write, we have two methods is there. We can use dielectric inserted method directly. It will be act as different capacitors. Means here this is series. It is capacitor C1, it is capacitor C2. Why not dielectric now? Different capacitance is there. So that's why. See here, first we can write by using dielectric constant. So now capacitance of the dielectric placed between the pair, that one. What is the formula now? C equal to epsilon naught A by D minus T1 minus T2 plus T1 by K1 plus T2 by K2. We can use this one. See here, this distance is D by 2, this distance is D by 2, total distance is D, its area is A, its area is A. This case we want to find out what is the equivalent capacitance. For that na C equivalence, what na formula? Epsilon naught A S by D minus T1 is D by 2. I write here D by 2. T2 is D by 2 plus D by 2 K1. Why? Because T1 is D by 2 plus T2 is D by 2 only, D by 2 K2. See here D by 2 D by 2 na D we can get is cancel. What we get na? Epsilon naught A by D by 2K1 plus D by 2K2. Yes na? See here epsilon naught A, we can take here LCM 2K1 K2 we can take here D common, here K2 here K1, means K2 plus K1 by 2K1 K2. So we can write here 2K1 K2 into epsilon naught A by K1 plus K2 by D. Yes na? It is the C equivalence. What we get C equivalence? 2k1 k2 by k1 plus k2 into epsilon naught A by D. It is the equivalent capacitance when two dielectrics are placed between the parallel plates. What now? Here see C equivalence equal to 2k1 k2 by k1 plus k2 into epsilon naught A by D. K1 is the first dielectric, k2 is the second dielectric. Or we can use series method. It is C1, it is C2, both are connected in series. That case what we can write now here, 1 by C equivalence equal to 1 by C1 plus 1 by C2. First C1 C1 means what? Here capacitance. When dielectric is placed means capacitance increases. What is the capacitance of first one? Epsilon naught A by D into K1. So C2 na epsilon naught A by D into K2 dielectric. So we can write here 1 by C equivalence equal to 1 by epsilon naught A into K1. What is the D now here? D by 2. We can write here K1 by D by 2. So here plus 1 by epsilon naught A by K2 by D by 2. Yes na? See here D by 2 changes na here. D by 2 means here 1 by C equivalence equal to D by 2 epsilon naught A K1 plus D by 2 epsilon naught A K2 we can get. So D by epsilon naught A common na 1 by C equivalence, that equal to D by epsilon naught A common. What we get now here, 1 by 2 K1 plus 1 by 2 K2. So here see D by epsilon naught A, here 2 K1 K2 LCM, K1 K2, here 2 K1 cancel, K2 here, here 2 K2 cancel, K1 here. Yes na? See it, we are getting this one. So means what we get, 1 by C equivalence equal to D by epsilon naught A into K1 plus K2 by 2K1 K2. Yes na? We want C equivalence na? C equivalence equal to what now we get? Epsilon naught A by D into 2K1 K2 by K1 plus K2. Yes na? It is the equivalence of equivalent capacitance when two dielectrics are placed between the parallel plate. What is the equivalent capacitance? Epsilon naught A by D into 2K1 K2 by K1 plus K2. So series method we can use directly dielectric capacitance of the dielectric placed between the parallel plate. That method we can use. Both are same. See here 2K1 K2 by K1 plus 2 epsilon naught A by D. Epsilon naught A by D. Here also see C equivalence equal to epsilon naught A by D to K1 K2 by K1 plus K2. Yes, now both are same. Whatever method we can use, solution will be same. It is the problem. Yes, now see for example, see this series case, parallel case. Now we can see one parallel case, one problem. See here, I write here, see this one. So this is the parallel plates, it is half, it is A by 2, it is A by 2. Here see, it is filled with dielectric. Yes na? It is dielectric constant is K1, its dielectric constant is K2. Yes na? See it is K2. Yes na? It is plus Q, it is minus Q. See here, what we can write now here, see if I use 1 by C equivalence equal to 1 by C1 plus, sorry, no need na. So C equivalence equal to what? C1 plus C2. Why na? Parallel plates. So parallel capacitors. What na? C1 we can write here. C1 equal to what? This one. Epsilon naught A by D into K actually formula. So here epsilon naught A means A by 2, yes 2D, K1, yes na C1, C2 na epsilon naught A by 2D K2. Yes na? See here A by 2, this distance is D only. Yes na? So correct only. C1 equal to epsilon naught A by D into K1. It is the formula actually. C equal to, so C1 na epsilon naught A means A by 2 D K1. C2 na epsilon naught A by 2 D K2. Yes na? See I write here C equivalence equal to C1 epsilon naught A K1 by 2D plus epsilon naught A K2 by 2D. What we get now here? C equivalence equal to epsilon naught A by 2D into K1 plus K2. It is the equivalent capacitance when, see, two capacitor means two dielectrics are placed. Above is half is different dielectric, below is different dielectrics. This case we can say it, we can say C1, it we can say C2, C1 C2 are connected parallelly. So that case what is the equivalence? C equivalence equal to C1 plus C2. C is formula is epsilon naught A by D into K. Capacitance increases when dielectric is placed between the plates. So what is the capacitance now? Epsilon naught A by D into K. A is here A by 2. Instead of here we can write A by 2. Here A by 2. K we can write K1. Here K2. Just we can write here simplify. This is the answer for when parallel plates. It will be act as parallel case. Dielectric filled parallelly. So that case this one. So what is the formula? Epsilon naught A by 2D into K1 plus K2. Yes, na? See. So I think it is very good. All of you understood. So please see the videos, like, subscribe the channel, and share to your friends and relatives. Please, it is very good content. Please subscribe my channel. Thank you.